So, good morning all. Today we'll be discussing about data link layer protocols. So, here this data link layer, again you studied in the OSA model as well as you have studied in the TCP/IP model as well, and it is the second layer. What is a data link layer? So data link layer is the second layer of the OSA model, and this layer transforms data, as you could see in the diagram. Like this layer is going to transform the data between nodes on the network segment over across the physical layer, and it provides the functional and procedural means to transfer data between network entities. And it is going to this layer is going to physically present not physically this layer is present between the physical layer and the network layer. So it has all the means to detect and possibly correct errors that can occur in the physical layer. Then I can so these are so it's a second layer, and it transforms data between nodes on the network segment over across the physical layer, and whenever there is an error occurs, it can able to detect and even possibly correct errors that can occur in the physical layer. So physical layer is the one that receives data in bits and bytes, and when receiving it, it can able to detect as well as it can possibly correct as errors as well. So it is a this particular layer is simply ensures and confirms that bits and bytes that are received are identical to bits and bytes being transferred. Okay, and here we came across two new terminologies, like the main functionality of the data link layer. Its main functionality is to transfer the datagram across an individual link. So in terms of each and every layer has its own keyword, and here the data is called as a datagram, and this datagram is transferred. So transferring of datagram across an individual link. So this is the main functionality of data link layer. So in this statement we came across two new terminologies, like one is the link, the other one is the datagram. So link is nothing but the communication channel through which the adjacent nodes are connected. You have different set of hosts or nodes. So the link is nothing but just a communication channel through which the adjacent nodes are connected. And the other term called as datagram. So assume like we are planning for a travel from Bangalore to some other remote place in West Bengal. So the entire travel will be involving three basic transportation, like flight, train, and then a bus. So now these three modes of transportation are independent of each other, and we assume the link to be direct in nature, but performs a basic service of moving you from one particular location to its adjacent location so that you can take the next service. So in this analogy, the one who is traveling, right, is the datagram. Each of the transportation segment the traveler is traveling is analogous to links, and each model used is the link layer protocol. So one who is traveling is the datagram, it's a data. Each of the transportation segments the traveler is traveling we can able to compare to links, and each mode is used is the link layer protocol. So the data link layer is the second layer from the bottom, and so it is going to define the format of the packet exchanged across the nodes, as well as the actions such as error detection, correction, retransmission, flow control. So many other features you would have already seen in OSA model. So and while talking about the addressing of data link layer in a computer network, in terms of network layer, it's an IP addressing. We use IP addresses, and in case of transport layer we use port address. And in terms of a data link layer, the data link layer also needs to have some kind of addresses so that it can able to identify the particular device. So for example, in a local area network or a LAN, the physical address of an Ethernet card, that is your MAC, right, is the address of the data link layer. So before delivering a packet to the next machine, the IP address needs to map to the destination MAC. So in order to map so your IP address to the MAC or MAC to the IP, we have a protocol called as ARP, which is going to translate an IP address to a MAC address. And simplest and what to say, yes. So in this let us quickly moving to the different set of protocols that are there in data link layer, and it will be seen quite interesting when compared to the other protocols. So we have 4 different protocols, like we have simple, stop and wait, go back in, and selective repeat. So go back in and selective repeat we will be discussing in detail in unit 4, and simple and stop and wait we will discuss we'll discuss in a explain manner or in a brief manner. Okay. So simplest protocol, so this is the simplest protocol as the simple protocol. So this is the one that has no flow or error control, and it is a unidirectional protocol. And you could see like get data from the network layer, the data link receives it and sends the frames to the physical layer, and the data frames are sent, and on the other end it receives frame, and via the data link layer it delivers the data to the network layer, and you have some set of algorithms for the sender side as well as the on the receiver end. So there is no need for flow control in this scheme. The data link layer at the sender side gets data from its network layer, makes a frame out of the data and sends it. The data link layer at the receiver side, you could see like so this is the data link at the receiver end. Site receives a frame from its physical layer, extracts data from the frame and delivers the data to its network layer. The data link layers of the sender and receiver provide transmission services for the network layers, and it uses the services provided by the physical layers. Okay, and you could see that in the given diagram, and there are some set of respective algorithms in the sender and the receiver side. So whenever there is a notification from the physical layer, or whenever a notification or the request from the network layer, the algorithm runs. That's what it has been designed. So the procedure at the sender side is constantly running, or the algorithm, right? So it is designed in such a way that the procedure, the algorithm at the sender side is constantly running, and there is no action until there is a request from the network layer. At the same side, like procedure at the receiver side is also constantly running, but there is no action until notification from the physical layer. So that you could see, that you would have seen from the previous diagram. So both procedures are constantly running because they don't know when the corresponding event will occur. Now this figure is explains about the communication using this protocol. It's very simple, that's why it is called as simple protocol. The sender sends a sequence of frames. Okay, you could see like the blue color one, the tilted one, right? That is called as frames. The sender sends a sequence of frames without even thinking about the receiver. To send 3 frames, 3 events occur at the sender side. The same way it has to receive it, right? So 3 events at the receiver side. Okay. So this is you could understand from the transmission time, height of the frame, like height of this particular place, no, from this place to this place, it's nothing but the transmission time. So the height of the box defines the transmission time difference between the first bit and the last bit in the frame. So this is what about your simple protocol. So if data frames arrive at the receiver side, for example, the problem here is whenever the data frame arrives at the receiver side, faster that they can be processed, the frames must be stored until their use. Normally, so data frames are arriving at the receiver side, faster that they can be processed. They have some capability, but receiver side it is receiving at a faster rate. So until it gets processed, it needs to be stored somewhere, right? So normally the receiver does not have enough storage space, especially if it is receiving data from many sources. The same way it will be receiving data from many sources, so it is going to result in discarding the frames or denial of service. There will be a delay. So in order to prevent the receiver from being overwhelmed with frames, we need some kind of mechanism to tell the sender to slow down. So there must be some kind of feedback from the receiver to the sender. So that is the problem. So how it is going to handle, that is what we will be discussing in the next protocol. Simple protocol, simply when there is a request, it is going to send the data frame, but there should be some kind of mechanism that should be there to slow down the rate of transferring of frames, right, so that the receiver does not get overwhelmed. Okay, now next comes the stop and wait protocol. As the name implies, you could see like stop and wait. So again there is the same kind of diagram, some kind of similar diagram, but there are some kind of differences you could see from the previous diagram and this diagram. In stop and wait protocol, the sender sends one frame. Okay, see, you could see in the diagram, the sender sends one frame, stops until it receives confirmation from the receiver. So sends a data frame and then an acknowledgement frame is received, sent from the receiver to the sender. So the sender is sending one frame. It is going to stop until it receives an acknowledgement or confirmation from the receiver, okay, to go ahead, so that it can send the next frame. So still we have unidirectional communication for data frames, but auxiliary acknowledgement frames travel from other direction. Okay, we added flow control to the simplest protocol. So we can see the traffic on the forward channel and the reverse channel. So now I'll show you the diagram. So this is the mechanism what in the earlier case we have it has sent all the three frames at once and it is going to receive an acknowledgement, right? So this figure we can see the traffic on the forward channel, that is from the sender to the receiver, and then the reverse channel. At any time there is either one data frame on the forward channel or one acknowledgement frame on the reverse channel. So we therefore need a half duplex link. So this protocol, the sender sends one frame and waits for the feedback from the receiver, so that it can understand that the frame has been received. Whenever the acknowledgement is received, the sender assumes that the frame has been properly sent from the particular sender, from its own, like from its place to the destination properly. Whenever the acknowledgement is arrived, the sender sends the next frame. Like here, like sending two frames in the protocol involves the sender in 4 events and receiver in 2 events. Go back and as I said, like the remaining 2 protocols like go back and selective repeat. So it's very simple. It's very simple that go back and protocol, because we will be discussing in detail in unit 4. Go back and automatic repeat request is again a data link protocol, but it is going to use a sliding window mechanism or in order to have a reliable communication. Okay, and how much size it can able to adjust the window size of n and the receiving window size of 1, that it will be in that case. And selective repeat protocol are also called a selective repeat ARQ. Again, it's a data link layer protocol. Again, that also uses sliding window mechanism for reliable delivery of data frames. Here, the only difference is it is going to send only the erroneous or lost frames will be retransmitted, while the good frames that will be received and gets buffered. That's all about the data link layer protocols. Thank you.